My name is Nitya Narasimhan. I'm a senior cloud advocate on the AI advocacy team at Microsoft. And today, I want to talk to you about how you can learn responsible AI practices by debugging open source models. Let's get started. So if you are someone who's working in the AI space, either as a new developer or a practiced data scientist, you probably have heard the term responsible AI. Today, I have a very simple agenda. What I want to do is start by explaining to you what responsible AI is. But then, if you're a developer, I want to get you started on your journey to converting those responsible AI principles into practice. And to do that, we're going to do two things. First, we're going to learn about an open source toolbox known as the Responsible AI Toolbox, which is also available as an integrated option in Azure Machine Learning Studio, so that when you're ready to operationalize your data flows, you can actually take what you've learned and apply it in product. Next, we're going to take a tour of this Responsible AI dashboard and understand exactly what it provides us that can help us debug our models for responsible AI practices. Then we'll look at two different demos. In the first, we're going to look at what you could do if you were training your own model and then deploying it and debugging it for responsible AI. We'll use an open source data set from Kaggle or from scikit-learn and get a sense of what you would have to do to build and train your model and then debug it with the responsible AI dashboard. But wait, what if you had more intuition to build? Where else could you go? In the second part, we look at how you can use pre-trained models from communities like Hugging Face and build your intuition further by just exploring those models with this dashboard to understand and get a better sense of how some of these components work to help you understand those principles. So let's first start by kind of setting the stage. Why should we care? If we're looking at the AI ecosystem today, the landscape is changing fast. Not only is AI innovating at a really fast pace, but the adoption both in enterprise and consumer spaces is super fast. And that means that users are beginning to have expectations, but we also know that governments and other organizations are looking at regulating this. So the core feeling is AI is moving fast, but can we make sure that these solutions do no harm, either to the user or to the platforms on which they run? So what does that mean for the people involved? If you're looking at AI development today, there are kind of different folks involved in that end-to-end experience. First, there are the people who build the models. Increasingly, I kind of think of developers as being in that mix because all of the things we're doing in responsible AI are shifting left. So now it's no longer just data scientists. It's regular developers who are picking up pre-trained models and fine-tuning them. So an AI model developer is the one who builds that model on which predictions are made, or in the case of generative AI, on which content is generated. Then there are decision makers, the people who make a decision how that model should be used or integrated into applications. What are the kinds of outcomes it is giving users? And then, of course, there's a user themselves. They're using the solution and they're trying to figure out, why did it take this decision for me? Why am I having this experience while somebody else has a different one? And what we need at this point is practical tools and guidelines that can help us as model developers debug it, as decision makers understand why that model made the decisions it did. And as users, we want to be able to give them trust in the through explainability, trust in why they saw that prediction and what they could do differently to get a desired outcome later. So where does responsible AI fit in? Responsible AI can be defined as an approach to developing, assessing, and deploying AI systems in a safe, trustworthy, and ethical way. At Microsoft, we follow these 6 principles for responsible AI: fairness, reliability, privacy and security, inclusiveness, transparency, and accountability. You'll notice that at the top, fairness. Fairness is really, really easy to understand. It's saying that if this model is taking decisions, let's make sure that it applies in a consistent way to everyone, that there is no one demographic that gets a different experience than another. Reliability and safety says, I may not have predicted everything that could happen, but let my system always work, even if the circumstances are things that I had not planned for. Privacy and security says, let that system protect the user's privacy, protect the data, make sure only authorized users can get access to the system. Inclusiveness says, hey, think about generative AI. I'm going to be using natural language Are the terms inclusive? Am I accessible in the way I'm building my systems? And under all this, we have these two foundational layers, transparency and accountability. Transparency is saying, I need to be able to explain why my AI system did what it did. And accountability is saying, I need to put checks and balances to make sure that when I do have something that happens, I'm able to run an audit or provide information that can help us understand why. So let's move on to the next part. We kind of hopefully have a sense of what responsible AI means. But as developers, we need to know how to apply it in our real world. So what is the responsible AI dashboard? So when you think about the responsible AI dashboard, think of it as a bunch of open source tools that exist today that have been created by various organizations, Microsoft Research, but also open source communities. There's a whole bunch of these, as you can see on this, error analysis, which helps you analyze the error rate distribution by specific cohorts. Interpret ML, that can kind of help you understand black box models, and prediction reasoning. FairLearn, that kind of helps you identify groups that may be disproportionately affected in your model. DICE, where you can basically do feature perturbations to understand counterfactual analysis. EconML, that lets you ask what-if questions for data-driven analysis. But what the responsible AI dashboard does is it takes these different tools and puts them behind a single pane of glass so that you as a developer don't have to work with every single tool independently. Instead, you take your model, you connect it to the dashboard, and the dashboard now gives you a unified interface into all of these open source tools with your model and your data set in mind. And that means that as a developer, not only do you have less of a burden for setup, but you can actually see the connections between various things and kind of work that into your developer flow. So how do you do that? You build the responsible AI dashboard from components. Under the hood, the responsible AI dashboard components can be broken into two buckets: model debugging and business decision-making. Model debugging insights help you understand how the model performs for different cohorts. So that's where you're looking at error analysis, data explorer, model OV, et cetera. So you're really trying to debug the model that you've built, look at the prediction, look at the metrics, and understand how you should be tuning it to ensure that it is acting responsibly. The business decision-making process, on the other hand, is looking at the predictions made and saying, what is this doing in terms of real-world impact? In the case of causal analysis, it might say, okay, a decision has happened in the real world. How can I determine what caused it? What is the one thing that I could change to potentially get a different outcome? How can I explain to the user why this happened and what they could have done differently to potentially get a different outcome? Counterfactual what-if allows us to perturb many features and say, if I changed these, what would happen to the prediction? So our goal in the responsible AI dashboard is to be able to allow a developer to pick the components they want and assemble a dashboard that is suitable for their needs in an end-to-end pipeline for assessment. So how does that actually work? Under the hood, we're using an open source toolkit called the Responsible AI Toolbox. I'll put the URL later. And what it does is it has a bunch of components. And in that, the Responsible AI dashboard covers the components in green. And that means that when you're conducting an end-to-end assessment, you're really walking through a workflow that has 4 steps. First is the identify step, where you're trying to identify what causes error rates in your model. Where are the areas, or where in your model are you having cohorts that have a higher than average error rate, and those that have a lower than average, so that you're making sure that you're not disproportionately affecting one demographic. Diagnosis is where you're going to then, once you've got those cohorts, you've recognized there's not an even distribution of errors, you're able to use tools to kind of dive into a cohort and see what caused it. Let's look at the data. Let's look at the model. Let's look at counterfactual analysis. Let's figure out how we could have changed this. And finally, there are the 2 steps, the mitigation and inform actions. We're not going to cover mitigation today, or inform actions, but we'll give you resources that you can look at. So hopefully at this point, you've got a fair sense of what the responsible AI dashboard is at a very abstract level. But it helps if you can actually see it in action, right? So to get that, I'm going to point you to this link. This is the link to the Responsible AI Toolbox. If you go to that link that you see at the bottom of the screen and look at the README, you will see this part which says useful links. There is a whole bunch of notebooks in there that will get you started. Today, we're going to start by taking a tour with the Responsible AI dashboard using that notebook. What that notebook does is actually shows you how the components work. And I'm going to take a look at it right here. It's going to show you how the components work. But as you'll see that I've mentioned here, it's using a census data. It's going to use a data set that gets census data and tries to assess the income level predictions from adult census data. So let's do a quick tour of what that Responsible AI Toolbox would look like. First of all, to get started, there is in the same notebooks, you will find a getting started guide that tells you how you would basically set yourself up. I'm not going to go into details now because later on when we see the two demos, we'll kind of quickly look at the code there. But just know that you're going to have a package that you'll install. You will train your model or get a predefined model, attach the Responsible AI dashboard to it, have it compute the insights, and then visualize it for you. So to take a quick tour, remember that we talked about the flow: identify the issues, diagnose, and mitigate. So the components that the dashboard will give you is very first, right off the top, you're going to see an error analysis dashboard. Before I come back into this, I'm going to show you what that actually looks like over here. So this is what the actual data set, the census data set looks like when you launch and run this dashboard, not the tour, but the actual notebook. And if you look at this, the code will give you all the insights that you need to know. If you go all the way to the bottom, it's going to show you an example of what the dashboard looks like. And this is what that error analysis component of that dashboard will actually look like. Now let's go back to the tour and you'll see how that's set up. So once that dashboard shows up, as you'll see here, you see a tree map, heat map, feature list, and a button here that says save as a new cohort. What you're going to do is you're going to go into this error analysis dashboard and you're going to create cohorts. Once you create these cohorts, you can then use those cohorts to dive deeper to understand whether one demographic or one subset of impacted people has a differentiation that you need to fix, right? How are you going to do that? If you look at this model, if you look at the visualization, you'll see that it's a tree of nodes in tree view. And what that gives you is it's kind of telling you which of the error rates on every node. The darker the color, the higher the error rate. The lighter the color, the lower the error rate. So what you're going to start off by is to really go look at the ones that are darker. And when you select one of those nodes, you're immediately going to see the selection of feature values that got you to that node. In other words, the subset of records that matched this combination of feature values is kind of the representation of this cohort. So you would go ahead and save your cohorts. You'd create cohorts for the high error rates. You might even create a cohort for something that is good. And now you've got, for comparison, multiple cohorts. So in this case, you can see that just looking at this, the high error rate one, it says 40% of the error is concentrated in data points of people who are married, have a higher education, and minimal capital gain. And so those are among all the different features, this selection came through that feature set. Once you've saved that cohort, you can then go ahead and start creating more cohorts and then analyze the data by cohort. So let's go and look back at the tour. We've done the error analysis, gone through the process of creating the cohorts. Remember that I showed you the tree map. You can also flip from the tree map. And the tree map, by the way, if you click the feature list, will give you the list of features in that model or data set that you were using. You can also flip into a heat map view. And what the heat map view allows you, and I think I probably don't have to, I'll show it in the slides in just a second, allows you to go in and compare two features and look at the kind of like intersectionality of features in the error rates. And then you'll see there's a Data Explorer tab. There is a Model Statistics tab. There is an interpretability tab. There is a local explanations and global under interpretability, counterfactuals, and causal inferencing. These are the different components of your dashboard. Now, in the tour, it's showing you what those look like. In reality, you choose which of these you want to plug in. So I'm going to go back to my slide so we can take a quick minute to just look at the different dashboards and understand what they do. We already talked about error analysis. You would start here. Once your model is there and you've registered a dashboard, you can go in and look at it and say, which of these have high error rates, save the cohorts that you want. And now you have a bunch of different cohorts you can analyze against. The tree view lets you study failure distribution by cohort. The heat map, which I talked about, allows you to then take a couple of features and then look at the distribution. Now you can tell from this that, you can see that there are blocks where 0% error, that's really good. Blocks 100% error, that's really bad. So start understanding intersectionality of features that are going to cause high error rates. In model overview, once you've got these cohorts, you can now load a cohort and look at the metrics, accuracy, precision, etc. How do they get impacted in that cohort? Are there cohorts that have higher accuracy or lower accuracy, higher precision, etc.? And then you can dive into the data explorer mode to kind of understand, is the data representative? So in this case, for instance, we are looking at it and saying, okay, in this particular cohort, can I look at the demographics, and is it possible that the data is not evenly represented across the different races? And you can see this in here. There's an abundance of purple where you can see that the color value for the race, that's for Caucasian white people. And then there's like American Indians, Asian Pacific Islanders, Black people, and other are not as well represented. So obviously this data needs to be balanced in order to be representative. Interpretability, on the other hand, lets you understand the impact of the features. From a global level, you can use this little slider and say, what are the features that impact that decision? The prediction we're making here is the income level for a particular person over 50K or under 50K. And the top 4 features you can see is marital status, education, capital gains, and age. This should immediately be interesting to you. Why is age a factor? Like, how are we actually representing that? But that's the aggregate feature importance. You can also dive into the individual. You can say, okay, for a particular individual, you can see that there are 165 incorrect predictions. I can pick up one of those rows and say, why did this person, this particular person, why did they get an incorrect prediction? And it can then analyze it and say, for this record, the features that had the highest impact were hours per week, education, capital gain, capital loss, occupation, and so on, which starts to give you a sense of, okay, there are these factors that we should look into and understand how we need to balance them better. What if counterfactuals is perturbation? You can go ahead and now try to say, what if I try to change the weight for this feature? What if I try to add this additional feature into the mix? What if I try to get more data to represent X? How does that change the outcome? Causal analysis, on the other hand, is really about real world action. Something has happened. What is a personalized intervention? Is there a policy that we could change to make sure that those decisions would be different for the user the next time? So with that, you've gotten like a sense of the different components of the Responsible AI dashboard. And we saw this for a use case, and there is a notebook that you can run to kind of look at that. But let's try to understand how you would actually do this if you wanted to try it yourself. So here, I'm going to go back to the README and have you pick up one of those notebooks. And by the way, by the time you see this, we'll probably have a link to a GitHub repo with those notebooks set up in a code space so you can try it out without any effort. But for now, you can go to the Responsible AI Toolbox site, check out that notebook that you see right there, and try to run it yourself. This particular notebook is using an open source Kaggle dataset that's for housing prediction. So what we're going to do is we're going to flip through and go and look at that dataset. So here is how we actually use it. So let me switch to the right one. What we're doing here is we have a dataset and a model that's trying to predict housing prices. It's using the Kaggle apartment housing prices dataset. And here, I just want to focus on the code and the steps that you're going to take in order for you to try doing this yourself. And there is a reason I'm bringing this particular example in. If you want to build your own intuition, you want to work with more open source tools and open source models. The Responsible AI Toolbox is already open source. Here, Kaggle has a lot of data sets. Here's an example of how you can use Kaggle's data set with scikit-learn to do your training for you. So what are you going to do? First, you're going to go ahead and import the necessary libraries. You're going to load the apartment data set and specify the different features, clean it and put it into a pandas data frame with the named columns. And once you clean and load the data, you can then go ahead and start training it. You can go through this code if you want, but if you're familiar with machine learning models, scikit-learn is one of the most popular libraries. You can start looking at this as a basis for you to try your own. I'm not going to go into the details here because the code is there for you to look at. I really want you to understand the flow. So if you use scikit-learn, loaded the data set, split it into training and test data, trained your model, and now at this point, you've got the split data set, taken a classifier, and you have a model that's ready to go. This is the example where you trained your own model from open source data using open source libraries. And for what it's worth, this was actually run on my laptop. So I wasn't even running it on the cloud. You can try this out with your personal device just to get a sense of intuition for how this works. Once that model is created, now you want to connect the Responsible AI dashboard so you can start debugging it. What you'll do now is make sure that you've installed the necessary libraries. If I kind of have the links to the code spaces, you don't even have to worry about installing them yourself because it'll all be set up for you. But if not, remember that the Responsible AI Toolbox site does have a getting started guide that you can use to set this up in your local environment. When you look at this, what you're doing is you're basically setting up two things. First, you're going to instantiate a Responsible AI dashboard. So let's kind of go down to the bottom and you'll see this. First, you're setting up a dashboard pipeline and you're identifying what it is, what kinds of insights you want to get from your data, and then figuring out what components you want to add. This is the point where you're going to say, well, I want interpretability, I want error analysis, I want counterfactuals. If you wanted to have other components added, you would go ahead and add them in here. Once you've gone and completed this step, you effectively trained your model, attach the Responsible AI dashboard, specify the components that you want. Now you're ready to have that dashboard generated. You go ahead and call compute. At this point, the computation is really going to go in and analyze all your model, the data, etc., and be ready to give you insights that can help you with making your model responsible. But how do you then view those insights? That's where you get the final step, where by calling the Responsible AI dashboard with this insights object, you get this. Wrong one, this one. So this is what you're going to get if you run that notebook. And the way it works, if you look at this, is it actually, and it's not running right now, I was running it before and it's kind of stopped, but it'll give you a URL right in here, a local server. And as you can see, this is what it looks like on the local server. This is an interactive dashboard that you can go into and kind of look at. So for example, I want to basically say, this is the model for the housing data set. Let's see the darkest one here. I'm looking at it and saying, okay, it looks like I'm having a high error rate for houses that have a screen porch value greater than 0, and the year the garage was built below is 1976. I can also go and say, okay, of all of these, the best errors, low error rates are for things that have no screen porch, living room area is greater or less than something, and the lot area is less than something. But you can also see that I can flip it here into, shift. You can flip it into the heat map and go and look at it and say, okay, show me what the heat map looks like for different things. And it's not running right now, but if I were running it, you would be able to see that. You can also go in here and look at the feature list of all the features that are in this data. So once you've done this, you can go in here and look at the cohorts. All data is for across all data. This is your, when you look at the model overview, it's giving you the precision, accuracy, and the other metrics for all the data in your model. But then remember that I could have picked a node and saved it as a cohort. And so I can look at now comparatively, how is the accuracy, precision, recall, or false positive and negative rates different for this cohort as compared to all data. If I were to now add a second cohort, which was for really good accuracy, I can also further understand what's the distinction between them. Next, data analysis. Over here, it's kind of giving me how my data, I can look at it in table view or chart view. It's giving me how that data is distributed across the predictions that were right and the predictions that were wrong. And what happens, we'll go into this later, but what happens is you can then kind of like pick one of these and dive into more details later. What I like to look at is the feature importance. This is where the interpretability comes in. You can look at this and say, among all, for the entire model as a whole, which were the features that had the most impact on the prediction? And you'll see that it's these, the overall quality. I think this is living area, total basement, square footage, and lot area. You can slide this and see the impact of all the different features. But you can also flip over and say, for a particular individual, what was the feature that mattered? So I can say, these are the ones that are incorrect. I'd like to know why that happened. And when you do that, you can go in and see what were, for that record, the features that had the maximum impact on their decision. So the same way you can go through counterfactuals and try all this out. hugely encourage you to go through these and try them yourself. But let me kind of wrap this up so we can go to the next step. So what did we do? If you want to try building, this was, remember, with tabular data, you're building a responsible AI dashboard using an open data set that has rows, columns, and features. And what you did is you loaded the data set using responsible AI utilities. You used scikit-learn to clean the data, split it for training. You had a classifier that you'd selected and used that to create your model. You did this all in your local notebook. Then you created a responsible AI insights dashboard using that open source responsible AI toolbox library. Attached, you specified the dashboard components you wanted, attached to the model, computed the insights, and then asked it to visualize it in that dashboard. So that's kind of a really basic workflow that you can use over and over again. Once you have that notebook, you can plug in a new data set, a new classifier, a new set of components, and reuse that to kind of get your intuition for tabular data. But wait, we know we are in the era of generative AI. And that means that there's a lot of other models out there. Plus, it's not just tabular anymore. We need to deal with text data. We need to deal with vision data. We need to understand how to debug models that are using natural language processing. And sometimes we don't want to train a model on our own data set. We might want to just take a pre-trained model, figure out whether that works for us, and maybe fine-tune it or refine it. How do we do that? So in the second example, I'm going to go look at how you can set up a workflow that'll help you pick up a model from a community like Hugging Face and use the Transformers library and their utilities to train and analyze, load a predefined model, and then attach that to the responsible AI dashboard so you can actually get your insights for those models. Let's see how that works. Oh, yes, but before I do that, I actually do need to say one other thing. Here, so far, we've been talking about the open source toolbox. But at some point, you want to productize. You want to be able to run this in a pipeline as part of your MLOps or LLMOps workflow. How do you do that? This is where I'm going to put this in the end resources as well. But we have a really good Learn module that will teach you how to use the same process, but do this in Azure. There is a sandbox available. You don't even need to have an Azure subscription to go and do this module. But what it'll do is it'll teach you how to train a model to predict whether a diabetes patient will get readmitted. Very famous data set and model. Predict that, and then it's going to help you walk through the steps for pushing the data set and training that model in Azure Machine Learning Studio, automatically getting the responsible AI dashboard associated with it, and then looking at the results there. So go check that out. It takes about an hour for you to get through that. But now I want to go look at the second part that I was talking about. The previous case, we were training a model from scratch, and we were using scikit-learn, and we were looking at just the data set from something like Kaggle. But now we want to look at text data and predefined models, pre-trained models. So we're going to try the second example that's in the Responsible AI Toolbox. So if you go look at that README, look for the one which says DBPedia text classification model. So let's go ahead and switch into the code again. I had this model running. Now, I will say that this model is not currently running. It took me pretty much quite a few hours to have it run overnight. And so I have the data and the dashboard pre-done, but we're going to walk through the code really quickly to see how it differs. So the first thing that we're going to do here is we need to load model and data. And in this particular thing, what we're doing is we're using Responsible AI dashboard to assess predictions on text classification for DBPedia data with a Hugging Face Transformers model. What you're going to do here is you're going to load the DBPedia dataset from Hugging Face. You're going to use the Transformers library to load tokenizers, the model, and the pipelines to actually build and train your model. Then you're going to attach the Responsible AI dashboard to it and analyze or look for insights into responsible AI usage and visualize them in the dashboard. Ready? First, we're going to do what we did before and load the model and data. The difference is now, rather than using write utils, you're really using the datasets library from Hugging Face, load it up into a pandas data frame, and then from Transformers, the Transformers library in Hugging Face, you're going to go ahead and have a pipeline and the tokenizers loaded in as well. Once you've got this, you can walk through this and look at the details of the code yourself. But the next step is you're going to load records. Now, By default, the notebook that you'll find in the repo will only have 6 test samples. Let me tell you that if you run it with 6 test samples, you'll get a really quick result, but there'll be no insights for you to look at because there really is nothing for you to see when you're only looking at predictions from 6 records. So 100 is a decent number. Just be warned that to get 100 of these like analyzed or like trained, it takes a little while. But what you're going to do here is you're going to load the data set, split it, and then you're going to go ahead and fetch a pre-trained Hugging Face model on this DBPedia data set. So I'm not sure if you're all familiar with Hugging Face, but if you go to the Hugging Face site, you will find not just data sets, but for a given data set, you can find out if people have trained models on it. You can also go to an existing pre-trained model and figure out how you can use it with your own data sets. So here we're fetching a pre-trained model on the DBPedia data set called DBPedia model. And once you've got both model and data set loaded, you're going to go ahead and have the Hugging Face library build you the pipeline to do the predictions. At this point, you should have a model created. So now you're going to wrap that model, and you're going to go ahead and start building the Responsible AI dashboard attached to it. Here, you're going to go ahead, same as before, create the Responsible AI dashboard, pick the components that you want, and then attach it to the model, and then you're going to have it run the insight or compute the insights on it. In this particular case, we're looking at Responsible AI text insights. So this text insights are still kind of, I think, early. There's still a lot of things to be worked out. Definitely go check out the documentation. But in this particular notebook, we're just trying to give you a sense of how you can get the workflow put together. What you actually get in terms of insights could improve over time. And so definitely keep an eye out during build to see what new features and capabilities are going to be released along with this. But for now, we're basically attaching the text insights Responsible AI dashboard, getting it to compute it. And then once it's computed, you'll see that this took fairly long time. I think if I go all the way to the end, it's about a few hours worth of time. It took me about 4 hours. And when it's done, it basically gives you a dashboard. Go ahead and ask it to build a dashboard on those insights, and you'll see it gives me a local host. It gives me a server that will actually host that interactive dashboard for me to look at right in my local device environment. And that is actually this particular dashboard that you see here. You'll see it says DBPedia, it's a widget. And now you see the exact same dashboard as before. We've already talked about what the different components of this dashboard are. So you can go ahead and say, again, what is which part of it has the highest error rates is for positive words greater than 47, which one has the lowest error rates. If I look for positive words less than 47, positive words less than, and positive words less than or equal to 7.5. So you can go through this and look at the different components of the dashboard, play with them. If you want to see the heat map or not, you can turn that on. You can go ahead and look at it from the dataset cohorts perspective, or go at it from the feature cohorts perspective. Go ahead, play with the data, play with the dashboard, try to kind of switch up, add a new cohort, remove one, and then try to understand what the metrics are telling you. So over here, for instance, you can kind of like, if you hover over it, the dashboard will give you insights into what that particular number means. But you should then kind of look at it and say, what does this mean for me in terms of understanding whether this particular cohort was overrepresented, underrepresented? Do I not have sufficient data? The sample size is actually one of the important things to look at. Is it possible that I just don't have enough data to make a clear distinction on whether that particular set of features was being representative and so on? So if you keep going further, you again can have the data analysis part. Over here, we had no incorrect prediction, so we can't really do much. If you go down into the feature importances, again, there are 83 features by their importance. Now, typically in this case, the two things you want to look at is you want to look at the top 4 or 5 features. Those are the ones that have the highest impact. Now, in this case, we're really just looking at the words. But if you're looking at stuff like diabetes, or if you're looking at the census data, for example, if you look at a feature that has a direct impact on a demographic like age or gender, and that shows up as one of the critical features, that's an immediate thing that you want to think about, like, hey, if that factor influences the decision, is that really being disproportionately impacting one subset of the audience? Again, as we did before, you can go ahead, pick one of these individual features. Now, over here, you'll see that I don't have many incorrect predictions. I can kind of go through this and look at what, for a particular record, what influenced it the most. This is because I only have 100 records, and I really didn't choose anything, so I just got 100 records. when you're doing this and you have the time, definitely try to increase the number of records or play around with the number that you're going to use. You'll also notice there was a step where it deliberately injected some false records in so we could have a more interesting dashboard. So go ahead, play with that and figure out how you can use that. So this gives you a sense of a workflow that you can now use. And this has this associated notebook. So you now have a notebook where you can go in and now try this with a different model, a different data set, walk through the same thing and kind of practice how this should work. So with that, what we saw in the demo that was different when you're coming to use Hugging Face models and text data, you loaded a data set from Hugging Face. You used their datasets library to basically load, clean, and use that data. You fetched a pre-trained model from Hugging Face using their transformers library. You built a pipeline using the transformers library. Then you instantiated the Responsible AI insights and attached it, computed the insights, attached the Responsible AI dashboard, got the visualization served to you locally. So with this, hopefully you've had a sense for the two different sides, how you can go ahead and start from data with something like Scikit-learn, train your own model, attach the dashboard and look at the insights, or how you can go to a place like Hugging Face, pick up pre-trained models, pre-trained data sets, and do the same thing. So where can you go from here? At this point, you might want to say, all right, I have these examples. And like I mentioned, there's a whole bunch of notebooks. There's housing data sets, census data sets. There's also some notebooks for vision. I have not played with those yet, but I encourage you to do so. But I want to leave you with 3 resources. Because when we talk about responsible AI, we only talked about model debugging today. There is still decision making. And yes, by the way, if you go into those notebooks, you will find that there's actually notebooks that are classified for model prediction, but there are also ones for decision making. So you can do counterfactual analysis, you can do causal analysis, understand what that should look like and what the dashboard looks like, and play with that as well. But I want to leave you with 3 resources. First, the Responsible AI Developer Hub. This is something my team has kind of put together and is maintaining. And what it'll provide you, and let me see if I can give you a quick sneak peek of that, is it's a site that has hands-on workshops. And you can see that we have a Responsible AI dashboard workshop right now. When you go into this, you should be able to see a video walkthrough of the entire module, or you can kind of go, and there's also slides that you can use to walk through it to understand what's happening. But basically, there is a workshop that you can do. You don't need an Azure subscription. Just log in, get started. It'll take you about an hour. What this does is it walks you through predicting whether a person would get readmitted to the hospital for diabetes within 30 days. And it's based on a very famous data set from UCI. It gives you a quick look at the various model debugging dashboards that we looked at today. Next, it also has 2 other components, 2 other workshops. One for content safety and one using prompt flow for evaluations. So let me quickly kind of give you a sense of why that matters. But before I do that, so that was the first thing. The second thing is I want to talk to you about the collection. So in addition to this, we actually have a collection that's been set up that if you kind of bookmark and follow, as new workshops, resources, features, and tools show up, we will keep updating this. So that very first thing is the module that I just talked about. You'll also notice that there's modules for responsible AI. There is a module for understanding fundamentals of responsible generative AI, which is going to look at things like content safety and evaluation. And then, of course, the documentation for where you can find all the relevant details. The third thing is Azure AI Studio. So let me tell you why this is important. To make the case for this, let's say that you're actually getting into the AI space right now because you know generative AI is a big deal. So how does what we talked about today fit into the broader scheme of generative AI applications? So what I want to talk to you about is a end-to-end application for generative AI called Contoso Chat that you can find at that other link that I've put in there. And what that gives you is a reference sample, if you will, that teaches you how to build a generative AI, chat AI application using Azure AI Studio. And in that, if you go to this blog post, you can now look at how responsible AI fits into the generative AI LLM ops workflow, as opposed to ML ops that we looked at before. And in this case, we're really looking at 2 things. If we look at the pipeline for LLM ops, as we kind of take our prompt and refine it and figure out how to engineer our prompts, look at retrieval augmented generation, all the usual stuff. What we're really doing is evaluating our pipeline. We're evaluating our workflow. And in this, we have evaluation metrics like relevance and coherency and fairness that you can kind of use tools available in Azure AI Studio with PromptFlow to figure out. So go check out this blog post to understand a little bit more about how evaluation works in PromptFlow. On the other side, once you've deployed it to production, we still need to make sure that responsible AI practices provide guardrails to the kinds of inputs people send us and to the outputs we send out from our systems. And that is provided by the Azure Content Safety Service. What that does is allows you to put guardrails on your application, which you can tighten. You can add filters and tighten or loosen as you prefer for your particular contexts. And the things that it can do is it can make sure that the words, the natural language used, is guarded against harm, threats of violence, and any kind of inappropriate behavior. You can also have it tightened against jailbreaking. You can have it flagged for copyrighted content, and so on. So the content safety filters is in production and another aspect of the responsible AI toolkit that you want to have as an AI developer. And to go back to the responsible AI developer hub, now it'll make sense to you on why we have 3 different workshops that you can go and explore. If you want to learn a little bit about Azure Content Safety, we have an early workshop. There will be an updated one coming up soon. So bookmark this site and check back. And then this is an early example of PromptFlow and evaluation. There are more things coming out at Build, so definitely do join us there. And with that, let me kind of wrap up what we were talking about. So the 3 resources you have for self-guided learning are the Responsible Developer Hub, the Responsible AI Collection, and the Azure AI Studio Code First Collection that will kind of give you resources for the generative AI side of things. This is the 6-part blog post that I just showed you. If you want to go look at it, it'll kind of walk you through the entire building of that generative AI application, including the part about the deployment and how content safety filters and evaluation is done. And with that, I kind of bring us to the end of this talk. This has been a really rapid tour of responsible AI. And what I hope you take away from this is the following. If I did my job right, you should be able to explain what responsible AI is. Specifically, you should be able to explain that it has 6 core principles. And responsible AI at the core is about making sure that the AI solutions we build do no harm either to the user or to the platform on which they run. We talked about what the responsible AI dashboard is. If you took one thing away from this talk, it is that the responsible AI dashboard is an open source collection of tools that the dashboard puts together behind a single pane of glass so that you as a developer don't have to work with those tools independently, but you get a cohesive, unified interface through which you can analyze your model for insights into responsible AI compliance. We quickly looked at the responsible AI dashboard features. Specifically, we looked at the 4 tools: error analysis, model, interpretability, and I'm blanking right now, counterfactual, and causal analysis. Once we did that, we looked at 2 different examples with code notebooks that and there are plenty more. In the first case, we looked at how you can train your model from scratch using scikit-learn and data from Kaggle, and then use that, it's a tabular data model, use that, attach it to the responsible AI dashboard to get insights into how that works for fairness, for the characteristics of your data, and so on. We also looked at how you could do the same thing with data sets and pre-trained models from Hugging Face. And finally, we kind of ended the show with a bunch of resources that you can look at to follow this through on your own. With that, thank you very much for sticking around to the end of this conversation. I do hope you will join us at Build. And please do keep an eye out on both that collection that I mentioned, as well as look for the developer keynotes and many of the sessions at Build, where you will learn about the latest tools. Very recently, the Responsible AI team has released a whole slew of new tools that can be used for generative AI workflows. And there will be more to come in terms of hands-on exercises, as well as documentation and utilities that you want to catch up on. Thank you so much, and I hope to see you at Build.